this simple machine is a simple metal bar with graduated numbers on a distance. As we can see, the distance is the same from every point, so we will simply use these units to refer to the distance. We have also these little weights that are each 50 grams, and we will refer to them as 1 unit of weight. What is the final result of this experiment that we are trying to reach? To measure the weight of an object that we don't know by confronting it with these weights, without using obviously this balance. This will be only used to test the results. So what we are using is a law of physics that is called the law of the torque, and that says that if we have one distance times another times a weight, and that result is the same as another, it will be balanced. What does it mean? That if I put a single weight on the 4 and then 2 weights on the 2, it will be balanced, because the weight times the distance is the same as these 2 weights times this distance from the center of the bar. How can we use it to measure one object we don't know the weight of? So obviously the force it gives, the one to calculate the torque, is its weight. So we must find a relation to a single piece, and then with trial and error find the most approximate proportion that we can find. So we start by putting this mass on the 1, and another of these masses on the 1 to see if what weighs more. As we can see, this one weighs more than 1, but if we put it on the 2, the bar will go this way. So this is between the weight of 1 of these and the weight of 2 of these. So it's between 50 grams and 85 grams and 100 grams. What we can do now is try other positions to narrow the scope, the range of the weight. What we can do now is, for example, try the 2, and we know now it's between the 2 and the 3. So it's not the same weight, but it can range from 3 to 4. So we try, and it weighs still more. So we know it's heavier than 75 because it's the middle range. We try the 3, and now it should be from the 3 onwards, but we will see with trial and error. Now it's heavier, but if we put it on the 5, it's balanced. That means that this weight times 3 times 5 is almost the same, it's balanced, it weighs a little more. It's almost the same as this weight times 3. So we have a proportion of 50 to this and 3 to 5. And we can see, calculating, that this mass has around 80 to 85 grams. We can now try. We have assumed that it's around 85, so with some masses like 50 grams, 20 grams, 20 grams, 10 grams, and one single piece of 5. And then try this. And it's around the same. So if we try with, if we try balancing it precisely with a scientific calculator, and this mass weighs 85 grams, and we calculated it only through the use of moment torque.
Excellent.